afternoon, ladies and gentlemen. It's Q&A Wednesday on a Thursday. I'm John.
I'm David.
And we're here to answer the concrete questions on the internet. Ding!
What's our question today,
Oh,
John?
sorry. Yeah. So from One High Voltage One. Awesome name.
Well, some name, yeah.
Not as good as Swedish Death Llama.
I don't know. High voltage, that's a pretty good name.
My other favorite one is
Johnny Bucci.
Joe!
DeBucci.
Joe!
DeBucci.
Okay.
That's my favorite one.
I get it.
Okay, one high voltage, ding! One high voltage one. So adding the colloidal silica, so this is from vlog 140, do you mind?
Duh.
She's always angry at me. Fixing segregation in your mix with colloidal silica. So let's say that video, quick little intro on that video. If you haven't seen it, go see it. You know what? I'm not going to give you an intro. No, I will. That's messed up. So that video was all about, you've got a mix that's already segregated. Use that colloidal silica to bring it back to life. Create a more homogeneous mix as opposed to paste over here, rock and sand over here, and water somewhere in between. So by adding the colloidal silica, the mix is able to hold up more water without segregation. Is this beneficial to prevent plastic shrinkage due to premature loss of water, e.g. sunny, windy day, and make it easier to finish? Oh my gosh, there's a lot here.
Several questions.
Several questions. Okay.
Q's and A.
Q's and A. Make it easier to finish the concrete, or is this the wrong approach? Stated differently, why should I want to have more water in the concrete? I'm going to go take a break. There's a lot of questions.
I think I need a glass of water.
Like a glass of water. So, I almost called one high voltage one Joe. So Joe,
DeBucci.
that was a weak DeBucci.
I'm tired of DeBucciing.
So one high voltage one, and I'm going to focus on a pavement here because I feel like we're talking about a pavement, right?
Likely.
Likely. So let's focus on a pavement, and why do I want to keep the water that was intended or designed for hydration in the mix is a couple fold. I'm going to start off with the chemical side, and then David is going to go into
Strength side.
the strength side. And what we're figuring, let me paint the picture a little bit better. Pavement for a state highway,
Sure.
30 feet wide, 2-lane highway,
Good example.
18 inches thick,
Sure.
6,500 PSI at 28 days. Flexural strength is 650 PSI.
Definitely in that range. That's, if it's not what the states require, it's close to it. You see 700, 750 flex.
Right.
Here and there.
Air content, 4.5 to 6.5%.
I think Colorado allows up to 8. But,
Okay.
In that range for sure.
And a slump of 4 to 6 inches.
Yeah, for pavement that might be a little bit high. 2 to 4.
2 to 4?
For pavers. We're using a paver.
Oh, with a small highway like that, I would think it would be hand placement. So let's just call it a slip form paver, 2 to 4 inch slump.
Right.
We still got the air 4.5 to 6.5.
Right.
With 7,500 at 28 days for compressive strength.
Right.
750 for flex. So I'm looking at, what is it, 730, 40 pounds total cementitious. Water cementitious ratio around 0.4, 0.42. 1250 on the sand, 1650 on the rock. A mid-range water reducer, since we only want a 2 to a 4 inch slump. So probably like 4 ounces per hundredweight on your mid-range. And then an air entrainment dosage of like half an ounce to an ounce per hundredweight.
Sounds delicious.
And nutritious. So why do we want to keep that mixed together? On a hydration side, if I'm the engineer and I'm designing it for a 0.42 water cementitious ratio, I want all that water to stay in there to give me as close as I can get to that 100% hydration. Anytime I'm removing water out of that system, long term I'm removing the very thing that's going to kick off the thermokinetics of cement hydration for unreacted or anhydrous cement. And ultimately that leads to a concrete that lasts longer, but is also stronger.
Sounds like it's my turn.
Yeah.
So, we hear over and over again, John, that, oh no, not more water is going to make it weaker. It's going to raise that water cement ratio, lower the strength. But as you allude to, I mean, we need the water in the mix that's going to make it strong. So if we make it too dry internally, it's not going to develop the strength, just like you said. And particularly with highways, a lot of times you start to see that on the surface. So we get that surface drying, and that is perhaps the worst thing that can happen. Because it makes it very weak, it makes it very brittle, it cracks up over a season or two because it just didn't have the surface strength. Because the water dried out from that surface. So on the strength side, I think what you said is exactly right. We want the amount of water we need to develop the strength, but we don't want to make it, too milkshaky. But we need water to get strength. We need the right amount of water to get strength.
And I think it can also be stated that if that water that was intended for hydration is allowed to bleed to the surface, or everything else consolidates and it gets squeezed out, now we're increasing our crack length and also bringing more water to the surface to reduce the strength at that surface, soften that concrete.
Concrete's got to be the only industry that loves bleeding.
Well, to a degree, we don't want to cut off all bleeding because, especially if you're working with the slip form paper or your hand placement, there are a lot of folks who don't like using evaporation retarders or finishing aids or a technology like this to reduce the impact of that evaporation or that solar radiation on the concrete surface.
Yeah, if we get a perfect balance where the bleeding comes up and it replaces the drying, and we're just absolutely certain that it's 100% perfectly balanced, then that's good.
It's never perfectly balanced.
Exactly the point I was leading to.
But that being said, to answer your other question, one high voltage one, we do see that the colloidal silica enhanced concretes hold on to moisture more, especially in those nastier environments. But hey, and the finishing is actually quite beautiful. I was just working with somebody the other day on that. Got some great pictures to show you too.
Oh, good.
That being said, if it's 30-mile-an-hour winds out, if it's 90 degrees Fahrenheit, and the sun is sitting overhead, probably shouldn't be pouring that day. Or you should be using a membrane-forming curing compound.
Yeah, that's right. I mean, I've said it before, I love the smell of mud at sunrise. I mean, most of these big jobs we're pouring just as soon as we can see.
Right.
So that's right. I mean, we need to do something to seal or preserve that moisture in the surface. And that's probably true almost all the time, but particularly true in those adverse conditions that you talked about.
Right, and I tell you, the colloidal silica will hold that in, but in those adverse conditions, we got to take excessive measures.
Yeah, extreme measures requires extreme fixes. So.
Amen.
Yeah. So I agree. But what we've seen in the field with the colloidal silica, using it as a topical, adding it back, it's literally like day and night, like good and bad. It really improves that surface. So.
Absolutely, and it's been very successful.
Very successful.
Especially rescuing slabs too.
Yeah, that too. So.
Anyway, hopefully we answered your question there, one high voltage one. Let us know if you got any more. Don't forget to like and subscribe. Ding that bell for notifications. Go, God, great!
Beat asphalt!